So at this point, we've determined we can modify the mission counts. There's a second parameter here for the fail count, but it only works for some mission types. So where do we find out about the mission types? Well, let's go ahead and relearn the game again. I'm actually going to do the unchanged game, so it's the original game now, without that edit that I did with the Nakoro. And I'm going to attach DME, just click hook over here. Successfully attached, and this would change if it's detected that you're in Wii mode. And whenever you stop the emulation, this will unhook. Your list will stay here, but it's all disabled, so you can still save at this point. But your list will maintain even if you relaunch the game and rehook. So you're not going to lose anything, but keep in mind this can crash caused by Dolphin doing some weirdness, so save often. Okay, so we're right here. I'm going to switch this to a string type, and if you're familiar with Cheat Engine, this should be no surprise to you. I'm going to look for the word mission. Sending this here. Okay, there's a ton of results. Quite a bit of results, and some are in the 817 range. I'm going to add them all just because. And unfortunately, unlike Cheat Engine, I can't just select everything here and say, oh, I want to see how long this is. So we're kind of hosed this way. You'd have to do it for one entry at a time, which is quite long. Lucky for me, though, I'm going to just right-click and say browse at this memory address, and we can see some of the names here. So we have enemy mission, we have timer mission, timer count mission, so this isn't a surprise, this would be the one that we saw on Central City, for example, and so on. Then there's ring mission, which we know that's only on on Circus Park. This is only for Circus Park. So while we're talking about that, I think Circus Park will be a great stage to figure out where the mission code is actually happening. So let's go here. I'm going to make a save state with Shift F1. And now I can just get back here really quick by pushing F1 to load the state. Okay, so I know already that I had happened to find some stuff with mission, but nothing concrete. So I'm going to go open here, look for my symbols. I've searched mission in the filter list. Change mission, debug mission clear. Okay, here we go. Here's more interesting. Main function. Mission manager task. Okay, this is probably our most promising starting point. But how did I get here? You're probably wondering if you're working on your own game. Here's how we would do this if I didn't have a symbol list. So, okay, we're not going to use this. I'm going to say, we need to find something promising with mission title. I need to know it's being used, so let's go ahead and just load the stage. Okay, so this stage is loaded. Let's do a new search. We're going to say ring mission. Alright, going to clear all this. Don't need this in my watch list. So we have 4 addresses here with a ring mission in the title, and they're all 804, so they're static. So this might not be too helpful, but we're going to give it a try. This is a boost function. That looks like it's a type. That's another type. And nothing happens here, but this doesn't end in a 4-byte, so I'm going to go back to 28, there's still more, 24, 20, and there we go. If I go further back than this, yep, that's a bar back as this. So there's mission, : ring mission. Okay, so this is more interesting for us. So I'm going to take this address and do a search for it, switching this to a word, hexadecimal, and what I'm doing here is I'm looking, is there any pointer that's pointing to the string ring mission. Search for this, hey, would you look at that? An 805 address is pointing to it, but that's also static, so we're going to do another search for that address. I got 2 more 805s. Let's do another search on those 2 results we got. Okay, 80B3ECC. This is more interesting because this is dynamic. So this is something that's pointing to this, which is static, which is pointing to this, and I'm sorry, these 2 are pointing both to this and to this. And I haven't done a search on this guy yet, so let's do that. We also got another 80B address right here. We could keep searching up, but I think that'll actually be the end of it. Let's do it anyway. Yep, no results for that 80B. Let's try the other one. And there is actually more results. And actually, that's interesting. We got another 805 address pointing to that 80B address. So this might be helpful. So, pointing to dynamic mission. And another 80B down here. Okay, so what is all this? What just happened? So all we did was we found mission ring mission, which seems promising that we'd think something's pointing to it. We took the address, we searched for that address, which means something is pointing to it, which would be these 2. So if I click this address, this is a pointer. Hey, look, there's the value of this. And if we actually add an offset of 0, we keep going down, switch this to a string, add this length. Hey, look at that, mission, ring mission. So this is pointing to something that's pointing to ring mission. So I could change all these to pointers to say mission, ring mission. There's not really a point though. I just want to see what they're looking at. This is probably our best bet. It's an 805 address, and it's pointing to our dynamic thing. So let's go ahead and deallocate this as a string. Type this out. Okay, so at this point, I'm going to add another save state with Shift F2, so it's not the same slot. I'm going to hit play. And instead of loading my save state, I'm going to quit just to see what happens over here. Okay, so this got flushed. This is now empty. I'm going to pick a different stage. Hey, would you look at that? Mission count mission. So we've already found something that's static, pointing to the dynamic mission change every time. So Black Doom looks like he has an enemy mission type. And Charmy has a count mission type, because it's just collect something, not destroy something. So it looks like what we found here is actually a hero mission pointer. I can't think of a better name for this right now, so we'll just go with that. So if I go to Space Gadget per se, we should be expecting timer goal mission. Hey, look at that, timer goal mission. Alright, so this is really good progress. We've already found something that's static between different levels. Mission goal mission for hero, that makes sense. Alright, sweet. So now we need to determine how is it picking what mission to go to per level. So honestly, we can get rid of all of this. This isn't helpful anymore, but this single piece is, and this doesn't look like this is of any use between missions. Yeah, this is just some static value at this point, and now it's 0, so we don't care what this is. If you actually look at what this is pointing to, this is pointing to something entirely different now, 810, because it's just dynamic memory. But it doesn't matter, it's always going to find the piece of memory we want for this status. Okay, so that's great and all, but where's this being determined? So the piece we probably care about is what is writing to this guy. We don't want to mess with this because this 81011 address, this is getting it's changing every level, right? So we'd run this just to confirm, quit, change levels. Sadly, this doesn't change real time. So look, 81011 450, close this, reopen it. Hey, look, now it's an 807, so it did change. So what is writing to this guy? So grab this address, the top one, pause the game, go to breakpoints. We're going to add a new breakpoint as a memory breakpoint because we're interested when this value is being written to. It's going to be a write, and we're going to break. I've had mixed success with using write to log and break, so I always just go with break. And if it's a case of constantly breaking, I use write to log, but for the sake of this, let's just use write and break. Okay, so I've added this breakpoint. I'm going to hit save. And I'm going to hit play, and nothing's happening. The game is still running just fine, nothing is broke. Let's quit the game. And hey, something just wrote to this at this strange address, and if we go ahead and look at our registers, it's saying R5, let's write to R4. So R5 is 0, write to R4, which hey, this address is this address, so it's saying stick 0 in here. So I think it's safe to call this function clear mission status. Or actually rather, clear mission pointer. All missions most likely. So I'm willing to guess, just by looking at this, this is hero mission, this is going to be either hero dark mission or neutral mission, and same down here. Maybe this is the mission manager struct or whatnot. We'll find out. We'll come back to this function. So I'm going to save this, I'm going to hit play. Nothing else wrote to this, it's currently null. And I'm going to go ahead and pick a mission of my choice. Let's do Iron Jungle again. Okay, so this already has mission count mission now. Sometimes this debugger doesn't quite catch the statement. It's kind of hard to explain. Dolphin is weird like that. So this probably is written on this next cycle, but it still broke before it, yet it shows up over here. Don't worry too much about that. Just know that this broke on this write. So we have a function here, it's saying store word R0 into R31. R0 is that R810, A7, whatever, that leads to this. And R31 is 80575F14, and hey look, that's over here. Great, so Let's go ahead and name this function. Write to hero mission slot. I'm terrible with naming. We're just gonna go with that. Play. Now it's count mission, and it doesn't look like that got written to anywhere else. Let's do this level really quick before I forget. So we can actually break these apart. So I'm going to stick these breakpoints separate from the main window here. I'm actually going to stick them up top because I'm only going to have a few. And I'm going to have the game running over here. Hit run. So we know pretty much if I pick any stage, like Glyphic Canyon, this function is always the one that seems to be hit. So at this point, I'm going to add a breakpoint to this function, and I'm going to get rid of this memory breakpoint. I'm going to save, and I'm actually going to kill Dolphin completely and relaunch it. And the reason for that is Dolphin is kind of unstable sometimes when you're using memory breakpoints, and I'd rather just not have it crash randomly while we're messing with this. So we're going to relaunch Dolphin here, relaunch the game. I could use my save states, but I'm not quite sure which one I launched last time. So just to be safe, I'm just going to do it manually. Okay, so we're back here, load. So I have a manual breakpoint now, and we're here. Okay, so what's happening? We know that let is writing to this address, I believe, at this point. R0 writing to R31, so if I step, go to the registers, R0 is this guy, R31 is 8060B, that is not it. So actually this function might not just be for here, this might be for all the missions, which probably makes more sense now that I'm thinking about it. Let's change this to write to missions. Or how about this? Determine mission for level. Save that. That might be a little bit more accurate. This gets called a few times. So I just realized I accidentally had 2 Dolphin instances running, which is why this wasn't showing up correctly. So now it is. Let's rerun this just to be sanity checking here. Let's hit play. That's 1 time, 2, 3, 4, 5, 6. So that function got hit 6 times. So something more might be going on there, but we know the final time it wrote to this. So with that in mind, let's not do this. Let's go back to that memory breakpoint like we had originally. Despite the instability. Loading a stage. Okay, so we wrote to this and I stopped here. So R0 at this point contains the mission identifier. So we want to trace back where R0 came from. So if we look up here, R0 came from R4. Okay, so what is R4? Did it get changed? It got changed at this point. It looks like we're going to need to, well, actually it's just +4 right here. So we can just open up a calculator, or we could just do this by hand since it's only 4. But just for sake of learning, you can use the Windows calculator. It might open up like this for you. You can just go up here and switch to programmer. You want to pick hex, and you're going to go to registers, grab R4, paste, -4. So 8060 B3DC. And 8060 in general is stack in GameCube games. Not always, but pretty much most of the time. So I'm going to copy this. So I'm expecting this to change all the time. This is not going to be like a static value or anything. Let's see if there's anything readable in text. Oh, there is. Mission, enemy mission. So hey, look at that. We're actually in a cycle where this is being written here. That makes sense. But now we might see this static this stack change all the time. Maybe we'll see the other missions as well. So R4 is a stack address, which means probably the parent wrote to it. Hey, look at that. R4 is assigned stack pointer +12. But for now, let's just save the breakpoints, clear it, and run the game. Look at that, the stack cleared, and it has junk in it. That's expected, but let's try running the startup sequence again and see if we can catch any other mission types. That was too fast. So let's do this. Let's stop inside of that the memory breakpoint. Okay, so it's determined mission for loading. So I'm going to re-add this, get rid of the memory breakpoint, save, play, restart the level. Okay, there we go. So skip down here. So the stack change is not going to help us. Mission count mission. Okay, so that's interesting. That actually helped us for the dark one. You use the same stack, ironically. You can't really rely on this though, but it's kind of nice that it worked out that way. Mission goal mission. Oh, and so that's the neutral. And so it's dark, then neutral. And eventually we should be saying hero. There it is. So dark, neutral, hero. So we've just cycled through all of them in this determined mission. So we've confirmed this is not just for hero. But now we know for sure that R4 is housing the data we're interested in. So we're no longer interested in that function we were in. We're interested in the function above it, which is a call stack here. It doesn't actually show the current function that you're in. You have to go to show PC to get back to where you were. And this is the last function that called it. Here we go. And the one that called this guy is the one below that, and so on and so forth. And this can go all the way up to the start of the game. But depending on how long the call stack is, it'll start truncating and not show everything. Okay, so now we don't care about any of these breakpoints except for this one. Make sure this guy's in there, saving this, hitting play. Let's restart the sequence one more time. Let's change it up. Let's go back to Iron Jungle, because why not? Alright. So I already see the stack as mission, enemy mission, already. This could just be invalid though, so let's not focus on that. Let's focus on this. So R4 gains stack pointer plus 12, and SP is always R1, just for your reference. So this plus 12 is ironically going to be C, because it's Dolphin represents this in decimal, and 12 in hex is C, so DC would be this. So it is the same. So R4 is being assigned to this value. So that still doesn't tell us where it's coming from. Let's see if we can figure that out. What about right here, before this function? What's happening here? What is R4's value at this point? (5F0). About the stack. D3DO. So let's just take a look at these parameters, what's being passed in this function. I'm suspicious of this function right here that happens right before this, because often common the functions above will be affecting what's in the stack pointer. So let's go ahead and take a look at the values in here. So let's take a look at R5, R6, R3, and R4. Although I should probably step once, there we go. So now R4 has the right value we're interested in. So let's take a look at R4. It's not a string. Take a look at the word. Okay, so there's a word of 41. X, it's 29. This might be significant or not. It is static, 805. Let's take a look at R3. Actually, we don't need to. Look at that. That's the same as this guy right here. Let's take a look at, shouldn't need to mess with R2, R6, and R5. R5 is 0, R6 is 1. Probably nothing too interesting for us. Let's step into this function. Step. What's going on over here? So we've just moved some registers around. We added R3. Let's check out what's in R3 now. Mission, enemy mission. It's a different reference. Nothing too interesting is happening here. I'm going to step out, accidentally stepped into this function. I'm not too interested in these functions. I'm more interested in what's happening here. Okay, this is a good sign. So BTCR, this is branch to whatever is in the control register. If you've used other assembly languages before, jump is essentially what this is. So this instruction right here is saying move whatever in R0 into the CTR register, and then here is saying jump to it. So if we go over here, CTR, look at that, 816B428. I'm gonna grab this address, go back to code, go to search address, and it jumps you here, which actually is this same function. Look, it's not too far down here. This is a good sign. If I had to guess, this is where the mission jumping is happening. So I'm going to go ahead and stick a breakpoint right here and right here. so we know we're on the enemy mission right now, which is the dark one. And when I go ahead and hit step, I jump down here. So I'm going to add a breakpoint here, just for my sanity, to see if we always go here, but we're not going to. I can already tell. Going to save this and hit play again. Now we're outside, back to where we were when we were wondering what R4 is. I'm not really interested in this anymore. I'm going to get rid of this. I'm going to rename this guy to Mission Determination Parent. Not quite sure what this does yet, but it's clearly related to missions. And then this new function that we're inspecting down here, if I'm going to guess, this is branch logic type of mission. So, back to show PC, we're down here now, I'm going to hit play. So now we're at the next cycle. Now it's mission goal mission. I'm going to go step, step. What I should have done is add a breakpoint to this BTCR, which I actually have one, so we're okay. Hit play. So what at this point is in R0? So this is doing a shift mask on R0 and putting the result back into R0. So R0 is only 2 at this point. After the instruction runs, it becomes 8. I'm not too worried about this logic, like what this is doing. We'll figure this out later. So R0 is 8. Then this is just getting some static address from R3. So R3 is set up here. So this is getting a constant. So R3 is constantly going to be this guy. So whatever this is important. Mission table, perhaps? This should be junk data if I have it as a string. Yep, nothing interesting, but it is a pointer to the execution code down below. So for now, call this mission table. Let's not make it a pointer. There we go. Put this in hex, just to make it look nice. So then we do a load 0. I forget what the X does here. I need to look this up. So this is a good example. So LWZX. IBM.com is a great resource for this. This is the result, this is the source, and this is the offset is what it seems like. So it's saying load R3 with an offset of R0 into R0. So this guy, plus 8, offset. So to do that, we can go over here, back to Dolphin memory editor. Oh, that was the wrong one. Add this watch. So this guy, quite literally plus 8. Make this a word, change this to hex. So that is where it's going to jump to, which is not the same as this one. This is just like the base mission table. So this is mission table plus 8, and we saw this should be goal mission based on this guy right here. Go down here, does that, moves to control register. Let's check out the control register. Hey, would you look at that? B46C right there. So we jump. This is different. It's over here now. It's doing some stuff I'm not too interested in. We can add another breakpoint just for sanity. Hit play. And that's it. So, kind of surprised there. I thought that was neutral. Maybe that was hero. Let's do this again. Don't care about this. Hitting play. Here we go. So what is an R0 at this point? 3, but that's before this RLWinM. I'm gonna hit shift. Now it's a C. Okay, so C. And hey, look at that. The stack is no longer relevant for us, so we can't go off of that. But I think it's pretty safe to say this is probably dark. So we're gonna call this guy plus C. Oops, I copied. Mission table plus C is probably dark, which was enemy mission on Iron Jungle. C here. Let's do hexadecimal. So B4C4 is what I'm expecting to see here. And it sure did jump to B4C4. Hit play, do the same thing. Skip this guy. Put R0, now it's a 4. Make a new copy of this. Mission table plus 4. Sure, I actually change this. I'm not actually sure which mission this is. This would be neutral, which this should be goal mission then. So my 8 might be wrong. That's probably count mission then. Sure this is right. B428. Yep, looks good. So this should be hero mission now. So it's 8. So yeah, this was coincidence that I saw mission goal mission. This is like old stack stuff, so this is not useful in the context of this. If I want to be positive which mission it was, I could check in the that other function we had found, which happens after this, to be safe. So we'll do that actually, just for sake of showing that off. So step, step, step. This jumps down here. I'm going to step out of this function. And I believe our original finding was in here, right? Yep, determine mission. And I know it happened down here, right? Store, somewhere in this function. I'm at a breakpoint here, hit play. So now we're in here. So this hero mission pointer should update to whatever type it really is. I believe it was right there. Yep, so it was a count mission. So this +8 is not goal mission. This is count mission. Like, okay, what was the point of this? Well, if my suspicion is correct, which from what we just saw, this is pretty much confirmed, these are the hard-coded addresses for the mission logic. So I should be able to, in theory, let's go ahead and clear these after saving them. I should be able to go to any mission of my choosing and change the mission based on this. So I'm going to go to Space Gadget, turn on the breakpoints. I might have actually missed it because that was too slow. I sure did. Got to reopen it with the breakpoints on. Okay, so now we're here again. Play. Now we're here. So dark was first. It's a 0. After it shifts, it's a 8, which would be count mission, which makes sense because the dark mission is destroying those 8 or those 6 little turret defense things. Let's go to the next one, which would be hero mission. Oh, I don't care about this anymore. Okay, so now this should be neutral mission. 4, which would be goal mission. Yep, seems right. Hit play again. Get to the next cycle. Here we go. This should be hero. 5. Step over this. Afterwards, it's 14. Okay, so that's a new one for us. Let's make a new table entry. +14. Not sure what this is, but it's probably the timer goal mission. That makes the most sense. This guy becomes +14. It should jump to 580. Unless I did my math wrong. Nope, jump to 580. And like I said before, we can go back to the next function leading up to this, right here. If I want to confirm what type it was, it stores it right here. Step. Hey, look at that. Mission, timer, goal mission. So we've confirmed what type it is. If I want to be formal, I could have the full thing. If I would add this to the official DME, I would want to have it nicely formatted and all that, but since this is just like scrap work, I'm not too worried about it. But we should be saving at this point. I should have saved a while ago. So I'm just going to call this mission research. Just in case it crashes, something weird things can happen all the time. Okay, so we have enough data here. Let's get rid of all the breakpoints except for this point, this loading the R3 modified by the R0. We don't care about anything else, so I cleared the list. I'm going to add this guy, oops, this one right here. Save, clear, play. And now, let's go ahead and pick a different mission and change it up. So let's do Iron Jungle, turn on the breakpoint, hit start. Okay, so we're at this point. Our 0 is C, which we know is a enemy mission. We're going to change this to 14, so it turns into a timer mission, if the theory is sound. Hit play. Now it's neutral, now it's hero, and now we're done. So now if I play this and I go to the dark guy, we should see a timer appear. We sure do. So I saw 26, so 23, 24. We also have a 1 over here. Let's go ahead and open up Nakoro again. Actually, I already have it open. So Iron Jungle. I have a 10 and a 5. That doesn't really make sense. Oh, you know why? I was using the original ISO, I think, so I'm going to use the modded one now, where it'll use those parameters. So we should see 10 seconds, and I think this will be ignored for this mission type. I may have missed it. I sure did. Let's do that again. Okay. Change this to 14. Hit play. Play again for neutral, for hero. So I gotta be quick about this. And there we go. So that seems right, and it should fail the mission. I'm gonna speed it up. And it fails. Sweet. So we've successfully changed that, but let's make sure the goal logic actually works, which I don't anticipate it won't, from what I just saw. So I'm just going to set this to something absurd like 5 minutes. And it doesn't seem like this matters at all for the that mission type, so this can go back to 0. Just make sure you have it, you don't want to be blank, otherwise you need the whole entry blank. Otherwise there'll be some parsing issues. Okay, so we actually saw the 1 out of 1 light up there, and I should see this as a dark mission. Sweet, so that's looking like it's working as intended. This video is long enough as is. Next time we're going to go over actually creating a Gecko code, because we're not quite done here, but this was like the main research core part of figuring out, okay, how is a mission picked? Where is it happening in code? Is there a hard-coded table? And we were able to do that from essentially nothing. Sure, I already had a symbol map, but we didn't really use it in this context. We did this all from just searching in DME and then making some memory breakpoints in Dolphin, then making regular breakpoints, and just trial and error, basically.